It is part 3, and we are using the sum and difference formulas again. So I've got them on the side up here. If you want to get out that paper again, you can, but still with sum and difference formulas. This is still section 5.4. Now I know, that's okay. I know we've got some things coming up here. Tomorrow is Junior Day, which wipes out almost all of you. And then Friday, I know, is Youth Leadership. So we're ready for a quiz. We're not going to do it tomorrow because pretty much everybody's going to be gone tomorrow. So that puts us to Friday, which I know still affects some of you. So if you're not going to be here Friday, if we can do it sometime tomorrow, we can. Like if you have 8th period study hall or something and you get back from Junior Day early, we can, talk about that, try to figure that out. Otherwise, Monday sometime we'll have to get that made up. So I may kind of talk to you about that a little bit more at the end of class, but not very good timing, but that is just kind of what happens. And binder check also on Friday. I think it's 29 to 42. So a couple big grades coming up. Now, formulas, here they are again, but you've got them wherever you need them. And I'm doing like 2 different types of problems today. They are all using those formulas, but this is just the first set of directions. It says write the expression as a sine, cosine, or tangent of an angle. Write the expression as a sine, cosine, or tangent of an angle. And we're pretty well going to work backwards on these problems. Instead of being given something like this on the left side, we're going to be given something like this that looks more spread out, and we'll have to condense it back down to what it would have started out as. So if you look at example 1 up here, it is very much spread out. It's got sine of 140 degrees, cosine of 50 degrees, plus cosine of 140 degrees, sine of 50 degrees. It's all spread out, and I have to condense it back down to what it would have started out as. Now, forget the 140 and the 50 for just a second, and let's just look at the order. Sine, cosine, plus cosine, sine. Sine, cosine, plus cosine, sine. If you look at your formulas, obviously it's not going to be tangent, but if you look at all of the others, you need to find the one that's in that order. Sine, cosine, plus cosine, sine. And I'm scanning through my formulas here. At the very top, sine, cosine, plus cosine, sine. It's matching up to the sine of u plus v formula. Now on our problem, the u is 140 degrees and the v is 50 degrees. So let's turn it back into what it would have started out as. I need sine in front, because this is the sine of u plus v formula. U is 140 degrees plus v, which is 50 degrees. So that's the first step, condensing it back down. Now, your directions said write it as a sine, cosine, or tangent of an angle, meaning only one angle. You don't want to leave these as 2 separate angles. Go ahead and add those up and turn it into sine of 190 degrees. that is what it would have started out as. So again, watch the order first. Match the order up. Then you can figure out the U and the V situation and put it all back together. Okay, we're going to try a couple more like this. These are the fairly easy problems today, as long as you have those formulas in front of you. So example 2, cosine of pi over 7 cosine of pi over 5 minus sine of pi over 7 sine of pi over 5. Okie doke. I'm looking at my order, cosine, cosine, minus sine, sine. Cosine, cosine, minus sine, sine. There you are. Cosine, cosine, minus sine, sine. So the U in this problem is pi over 7. The V is pi over 5. Now be careful, even though there's a minus right here, it's matching up to the cosine of U plus V formula. So we need to put cosine of pi over 7 plus pi over 5. Cosine is just kind of backwards. Okay, well I should add those numbers up because it needs to just be a single angle. Now these are fractions, and in order to add fractions, what do we need? Common denominators. I think the LCD is just 35, so I'll take that first fraction times 5 on top and bottom. The second times 7 on top and bottom. And here we go. This turns into cosine of 5 pi over 35 plus 7 pi over 35. I'm just showing you what it looks like with the common denominators. Now add the numerators. 5 pi plus 7 pi is 12 pi. And make sure that your answer still has cosine in front. A lot of times we just start working with these numbers and we kind of forget to put it with that trig function out front. The whole thing would be your answer. Okie dokie. Questions so far? All right, there's one more of these. I just want to try one that has tangent. So tangent of 5 pi over 4 minus tangent of pi over 12 all over 1 plus tangent of 5 pi over 4 times tangent of pi over 12. Now I already know it's tangent. That's pretty obvious. You've got tangents all over the place, but we need to pay attention to the signs. There's a minus on top, plus on bottom. Minus on top, plus on bottom. This is matching up to the tangent of U minus V. And U in our problem is 5 pi over 4. V is pi over 12. Now, the order didn't really matter too much when it was a sum, but subtraction is not commutative, so you have to put it in this order. 5 pi over 4 minus pi over 12. It would not be the same thing if you switched those around. So to put it in the right order, pick out U, pick out V, and just make sure it's U minus V. Now LCD in this case would be 12, so I'm going to multiply top and bottom of that first fraction by 3. And now it says tangent of 15 pi over 12 minus pi over 12. That would be tangent of 14 pi over 12. Anything else we could do to that number? Yeah, let's reduce that. It just didn't feel right. Divide by 2 on top and bottom, and so that would be tangent of 7 pi over 6. Okie doke. Questions about working backwards, going from the spread out version to the condensed version. Okay, now the last 2 examples, I will admit, are like totally different than this. We are still going to use some of these formulas, but we're like totally switching gears here with number 4 and number 5. Now, good news is these directions apply to both number 4 and number 5. So they are pretty important directions. You'll want to write these down. It says find the exact value. Find the exact value of the expression given that sine of u is negative 12/13, cosine of v is 4/5. And there's something else that's kind of nice here. They're telling us that both u and v are in quadrant 4. U and v are just like 2 different angles, but both of those angles are in quad 4. Okay, so let's see what we have to find with number 4. It says sine of u minus v. Sine of u minus v. Now, before I use those numbers up there, let me just go back to the formula for the sine of u minus v. Let's write this out real quick. Sine of u cosine of v minus cosine of u sine of v. Now, once we get it written out just according to the formula, now we should be able to plug in some numbers. Okay, and usually at this point I'm using handy dandy to evaluate all of these different trig functions, but I'm not really doing that on this problem. Okay, sine of u, oh, right there, sine of u. They told me that earlier. It is negative 12/13. So I plug that in for the first part. All right, cosine of v. What do you know? That one's over here. Cosine of v, that is 4/5. I don't know why that fraction looks so much shorter than the other one, but they're both fractions there. Negative 12/13 and times 4/5. Now we have to subtract cosine of u times sine of v. But hang on a second. Did they give us cosine of u? No, bummer. We don't know cosine of u. So let's think about how we could find cosine of u. Okay, remember u is just some angle in quadrant 4. Now, if I'm in quadrant 4, boom, right here, I could probably sketch a right triangle like I'm in quadrant 4, and then maybe use some of that other information to help me label the triangle. Let's try to start there. Okay, here it is. The right angle is over there. Now, where handy dandy said theta, let's not put theta. Let's be a little bit more specific. We are working with u right now. So let's label u instead of theta. Okay, now how could I start to label that? If we go back to good old SOHCAHTOA, sine is opposite over hypotenuse. Hypotenuse has to be positive, so that tells me the 12 is negative and the 13 is positive. Now, if I'm about ready to find cosine of u, I am going to need the adjacent side. So what could I do to find the missing side? Pythagorean theorem, yes. You can call that A if you want, A or B. And so here it is, A squared plus B squared equals 13 squared. Now, this is a 144. That is a 169. If you subtract the 144, I think you'll get back a 25. Now square root, and we are going to have to pay attention to the positives and the negatives. If we are in quadrant 4, should this side be positive or negative? Positive. It's labeled on handy dandy if you can't really see that. So we need to put 5 up there. That is our missing side. And now look at us. Cosine of u, it would be adjacent, which is 5, over hypotenuse, which is 13. Now I know cosine of u. Okay, now be careful with the next part. The next thing I have to find, the last thing I have to find, is sine of v. Don't use this triangle though, because this was for u. We are needing v with this last part. So even though you're not going to want to draw another right triangle, we technically should, because u and v are two different angles in quadrant 4. Okay, so again, instead of putting theta right here like handy dandy has, we want to put v. And so let's start to label this triangle. This is the u triangle, this is the v triangle. Cosine of v is 4/5. SOHCAHTOA tells me that cosine is adjacent over hypotenuse. So 4 on top, 5 for the hypotenuse. And here we go again. We need to find that missing side. I'm calling it B. You can call it A or B, doesn't really matter. And here we go again. This is going to say 4 squared plus B squared equals 5 squared. Now let's think about what happens here. I'll be taking 25 minus 16, which is 9. And be careful, if I'm in quadrant 4, does this side need to be positive or negative? Negative. We need to put -3 over there. So back to what we're doing, sine of v. That would be opposite over hypotenuse, so -3/5. Okay, I still need to multiply that out and simplify it. Any questions about how we got those last couple values? It's important to draw different angles for, or different triangles for each one. Now this will turn into -48 over 65. You've got 2 minus signs in the back, so that'll turn into plus 15 over 65. And just like we've been doing all along, anytime we have common denominators, we want to go ahead and put those together. So keep the 65 on bottom and type in, if you need to, -48 plus 15. That is -33 over 65. That would finally be our answer for number 4. Any questions at all about that one? Yep.
Do you mind if I just grab a couch?
Sure, yes, that is fine. There you go. Now, good part about number 5 is there's going to be something different to find. It's not going to be sine of u minus v, but all of that information is the same, which means our triangles will be the same. So you can reuse those triangles on number 5. That's how your homework is set up as well. You'll draw the triangles once and then use it for a few problems. You may have to draw some other triangles again later on, but they'll be good for a few problems after that. Okay, so last one. It does get a little bit hairy when we simplify this problem because it's tangent and it's set up as a fraction. So watch carefully here. I'm just recopying the formula. We want tangent of u plus v. So this is what I need. Tangent of u plus tangent of v all over 1 minus tangent of u tangent of v. Now you guys already have these on your paper, so don't recopy them. I'm just putting them back up here because it's a new slide. And let's start to plug in what we have. Tangent of u. Use the u triangle, not the v triangle. Kind of confusing, but if it's tangent of u, go up here, and tangent is opposite over adjacent. So that is negative 12/5. Okay, to that I need to add tangent of v. We're moving down here to the v triangle. Tangent is opposite over adjacent, so I'm not going to put plus negative 3/4. I just changed it to minus 3/4. Make sure you know these numbers are not being multiplied. Technically, they were being added together. It's just that second number happened to be negative. Okie doke. On bottom, you can go ahead and put the 1 minus. Now I have to take tangent of u, which is negative 12/5. I put it in parentheses just so my brain knows it's going to get multiplied by something. And it sure does. It gets multiplied by tangent of v, which was negative 3/4. Now, we're going to have to work on the top and bottom separately for a little bit until we can maybe do a little keep, change, flip later on. But if you go back to the top, you're going to need some common denominators to actually subtract those. And I think the LCD is just 20. So multiply the first fraction by 4, the second by 5. Here we go. Negative 48 over 20 minus 15 over 20. I will subtract those actually here in just a second. Now on bottom, you really need to multiply first. So negative 12/5 times negative 3/4. You can keep the 1 minus out front. But when you multiply those out, you get 36 over 20. And there should technically be a minus in front still. Now, if you go back to the top, all you need to figure out is negative 48 minus 15. That should give you negative 63 over 20. And to do this part on bottom, you also need common denominators, but this is a little bit easier to do. Think of the 1, I'm just going to scribble it out here. Think of the 1 as 20 over 20. Anything divided by itself is 1. And I picked 20 because that's my denominator over here. So 20 minus 36 is negative 16 over 20. Okie doke. Now we can go ahead and keep, change, flip. Are there any questions up until this part? Told you it gets a little messy when you simplify with tangent. So keep the negative 63 over 20, change it to multiply, and then flip the fraction on bottom. Now, nice part is that the 20s cancel. Also, a negative times a negative is a positive. So I'm barely gonna squeeze this in over here. I don't think that reduces. So it'll just be 63 over 16. That is tangent of u plus v. All right, any questions about that? Again, two totally different types of problems, but both of them referring back to those formulas. So here's T42 from page 381. You got a little over 15 minutes left, so that's pretty good. We're going to do 27 to 34, and then 43 to 50. So I'll let you start on that, and then we'll talk a little bit more at the end about our quiz coming up Friday.